Okay, so it's the 14th of May 1977, and actually this time we're going to be working with Aries initially to get our Polaris data. However, before we can get started on that, I've got this concern about what the chronometer time actually is. I've got a 3 seconds fast error, which is easily applied. I'm just going to take that 3 seconds off my chronometer time at the moment, but it's this 02 that could cause me some problems because I don't know at the moment if that's AM or PM. There is a clue in the question. I'm told that it's the morning twilight. So if we go over again to our LMT table, we've actually got the details of the times of nautical and civil twilight in the morning and also in the evening for the 14th of May here. I don't need to be terribly precise about this, so where you've seen in amplitude questions very accurately working out a latitude correction before applying LIT, we don't actually need to worry about this so much here because this step is purely to confirm whether that is AM or PM. So I'm not going to go to the trouble of using the table and stuff now. I can just do a quick check. It's morning twilight, and conventionally morning twilight that we use for observations is going to be closer to civil twilight than nautical, simply because the horizon is more visible at that stage. The sun's actually closer to the horizon, so you can actually work more accurately there, but you could in theory do some sites closer to nautical twilight. Let's assume that morning twilight is our conventional civil twilight, and let's find a latitude that's close enough to our own so that we can do a quick check and get an approximate GMT of the morning twilight in our location. So my latitude is 3714.0 north, so if I were to go for the 35 degrees north latitude and take the LMT of civil twilight from there of 429, and I'm just going to skip this bit with the increment for the latitude correction. I'm just going to go straight to an approximate LMT. So the LMT of 0429, and that's for 35 degrees north. That's the LMT. To get from an LMT to a GMT, we have to apply longitude in time. So I can go to my longitude of 152, and that's west. So when I divide that by 15 and get 10 hours and 8 minutes, the fact that it's west means that I'm going to be adding that on to my LMT to get GMT. Remember, the time in the Western Hemisphere is going to be behind that in Greenwich, so I'm going to add this on to my LMT. You can probably already see what's going to happen here. That my approximate GMT for morning twilight in my longitude is going to be about 1437. So really important to remember here that that was just a check. That is not the GMT I'm going to be working from. The most important thing about this is the fact it's given me an hour that's in the afternoon. It's about 20 to, according to this, it's about half past 2, 20 to 3 in the afternoon in Greenwich. So if I look at my chronometer, which gives me GMT, I can see that 02 is actually going to be a 14. It's a 12-hour clock, so I needed to do this to confirm, but I can actually see that that is going to be close to 1437. So that's going to be 14, which means my overall GMT for use in the calculation is 14:30:00, because I'm going to subtract that 3 seconds fast, and that's going to be my starting point for calculating my latitude by Polaris, because I'm going to get the LHA of Aries for that particular time.